Hello and welcome to this video. In this video we're going to talk about how would we solve graphical inequalities. So we've always said that with inequalities we treat them exactly the same as we would equalities or equations, but we just have a different symbol, and so instead of getting one value we'll get a range of values. So we're going to plot inequalities on a graph the exact same way that we would plot an equation on a graph. So if we said we had a linear inequality, so let's say that y is greater than x plus 3, so this is in the form y equals mx plus c, but we've just changed it to y is greater than mx plus c, where m is 1. If you wanted to plot, so the thing you would plot is you would plot y is equal to x plus 3. And to do that, we're going to need some axes. So let's bring some axes down. There we go. So we have some axes for us to plot on. Okay, so if we want to plot y is equal to x plus 3, I'm just going to do a rough sketch of it just to get the idea of why it's different when we have inequalities. But you could easily plot this just by making that table and then plotting the coordinates and then drawing a straight line through it. But what I know is that I'm going to have it passing through plus 3 here, and it's going to have a positive 1 gradient, which means it's going to look probably something like this. Okay, and this is the graph of y is equal to x plus 3. Now, if I wanted to plot y is greater than x plus 3, it means I need to find all of the values where y is bigger than it would be if it was equal to this. Okay, so let me put this another way. So let's say that if I were to find any value of x that is beneath this line here, all of these values of y will be things like 2, 1, 0, minus 1, and so underneath this line, y is less than x plus 3, okay, because this line is where y is equal to it. If we go underneath it, it's where it's less than. So if we go above it, anything above this line is going to be y is 4, y is 5, y is 6, and so on, okay? So what this means is that if we wanted to we usually ask to shade the area. So we shade the area which satisfies this inequality up here. We shade everything that's above this side. So we get all of this in. Okay. In terms of the questions they can ask you about this, they're probably not going to ask you questions where they just give you one inequality. They usually will give you maybe 2 or 3, and they'll ask you to shade the region that satisfies all 3 inequalities. So let's have an example of that. So let's look at some other inequalities. So let's keep this one. Let's say we know that y is greater than x plus 3, but let's also say now that y has to be less than 5, and let's also say that x has to be greater than minus 1. Okay, these are the 3 example inequalities that I just made up that we could plot, and we want to shade a region that satisfies all 3 of these inequalities. So let me just get some axes back here. So these are our axes that we're going to plot on. We said that the y is greater than x plus 3. We first plot y is equal to x plus 3, which is going to pass through 3, and it's going to have a positive 1 gradient, which means it's going to follow a line that looks something like this. If y is less than 5, then we need to find where 5 is, which is going to be about here somewhere, if we have a big gap there for 3. And we need to plot the line y is equal to 5, and the line y is equal to 5 is just going to be a horizontal line that goes across here. Let's extend this a bit further there, and goes across here as well. Okay, so this is y is equal to 5. And then x is greater than minus 1. We find where x is minus 1, let's say that was here, and where x is minus 1, we draw a line down through all of the y values where x is equal to minus 1. Okay? Now they're asking you to shade the region, so they'd say shade the region that satisfies these inequalities, which satisfies these inequalities. Okay, this is what the question would say. And so we've plotted what each of the lines would look like. If there's a region they want us to shade, hint is they're usually going to have the region that's enclosed by the 3. So you can see this triangle, but let's always check, because sometimes they can do this to throw you off, so just make sure. So if we said that y was greater than x plus 3, we had everything above this line. So I'd probably label this y equals x plus 3, this one was y equals 5, and this one was y equals, or x equals even. This was x equals minus 1. Okay, so everything greater than x plus 3 is up here in this region. Everything less than 5 is below this 5. So now we've narrowed it down to everything above here. And if it's everything in here is satisfying both of those two. If we add in this one, then it has to be greater than minus 1. And so it has to be indeed this region that's enclosed by the 3 inequalities. And this is graphical inequalities. This is essentially the most difficult kind of question that they're going to ask. It will usually be this region that they kind of seal off with the 3. Your method will always be to just plot out. So if we were to write a method for it, we'd say the method would be first plot the equations, as in when they're equations they're equal to, not greater than or less than or any of that. So plot the equations and then shade the regions. It's usually the region enclosed, okay? But I would say as a hint, don't just see that a region is enclosed and instantly assume that that is the region that they want you to shade. It is going to be most of the time, so it's a helpful hint if you have no idea how to where to place these things. Go for the region that's enclosed by it, and it's a good way to make a guesstimate or an educated guess. Okay, so this is graphical inequalities. Hopefully this helps, and thank you for watching. Hello, and welcome to this video. In this video we're going to go through some practice questions on the topic of inequalities graphically. So this first question, we've been given this shaded region here, and they're asking us to write down the inequalities to fully define the shaded region. So what we've said before is they're always going to be a collection of lines, and so we just have to see what is the equation of this line, what's the equation of this line, what's the equation of this line, and what's the equation of this line, and is it greater than or less than that. So to fully define the shaded region, let's first look at this line. So this line goes through y is equal to 3, and so this equation for this would be y is equal to 3, but since we're looking at the shaded region is below it, so y is less than 3 is the first of our 4 that we're going to have. The second one is below, and this goes through y is equal to 1, but it's looking at everything above y is equal to 1, so our second inequality is y is greater than 1. Our third inequality is going to be this line here. This line here is x equals 4, but we're looking at everything left to the x equals 4, which means we're looking at everything less than 4. So this is x is less than 4, and then you can probably guess on the other side it goes x equals minus 2, but because we're looking at everything greater than that, this is going to be x is greater than minus 2. So these are our collection of 4 inequalities that fully define this shaded region here. Okay, and so now let's go on to a slightly more difficult question here. So on the grid, shade the region that satisfies all these inequalities. So we've said in order to solve questions like this, we want to first plot these as if they were equations. So we want to plot this as if it was y is equal to 1. This one we're going to have to rearrange slightly because we always want it to be a y equals to something. So we're going to rearrange, we're going to move this x to this side, and we're going to plot y is equal to 5 minus x. And we'll see what that looks like in a second. And this we're going to plot y is equal to 2x. So y is equal to 1, we just find where y is equal to 1, and then we draw a line across. So no matter what x value we have, the y value is always 1 along this line. And we can think at this point, we know if y is going to be greater than 1, it has to be something above this line. So we're going to get something above here. Then y equals 5 minus x, and we're going to pass through this point of 5, since 5 is the y-intercept. But the gradient of this is minus 1, which means that as we go along 1, we have to go down 1. And so our next point is going to be here, along 1, down 1. We're going to go there, along 1, down 1. And then you'll see this pattern. And then we just have to draw in this line as straight as possible. You guys will use a ruler to draw this line as accurately as possible. Now we're looking for something where y, so this is going to become y is less than 5 minus x. So we're looking for things that mean that we're going to be below this region. So we are looking so far at this enclosed region here. Okay, and lastly we're going to plot y is equal to 2x. So it's got a plus 0 on the end that we can't see, so the intercept is 0. When y equals 1, when x equals 1, y equals 2, 2, 4, 3, 6, minus 1, minus 2, minus 2, minus 4, minus 3, minus 6. And then we draw a straight line through all of that. And now we want to check, is y greater than 2x in this region here or in this larger region here? And if we think y is greater, we're always going to go with the region that looks like it's going to go up on the y scale. Okay, so everything in this region where we're looking above, so everything this side of this line satisfies this inequality. So y is greater than 2x. Because any point that we choose, let me just draw that line back there, any point that we choose in this region is always going to satisfy this inequality. So we could choose, for example, let's say this point, okay, where the y value is going to be greater than minus 2 times 2. And minus 2 times 2 is going to give us minus 4, so y is equal to 2 is greater than that. If we were to choose anything on this side, let's say we had this side where x equals 5 and y equals 2, well, x times 2, so 5 times 2 is going to give you 10, and so 2 is not bigger than 10, so that wouldn't work. So that means that although we've got this nice triangle, this is a little bit of a trick in this question, because this region here is R. So to make it explicit, I'm just going to shade the outer edge. You wouldn't do this in the exam, but it's just to make sure you know which region it is. This region here is region R, because it's the one that's above the line y equals 1, and below the line y is 5 minus x, and above the line that y is equal to 2x. So you would leave your answer like this. Okay, and now finally, this one, we've been given some regions where we want to show by shading the region defined by the inequalities. So you can see here we've got actually equal signs. Now these equal signs, we're going to come to it in a bit to see if they change anything. But first we have to remember to plot all of these lines. So we're going to plot y is equal to minus 1, and when y is equal to minus 1, that's going to be this point across here. Okay. When y is less than 4 minus x, we know its y-intercept is 4, its gradient is minus 1, so when we go across 1, we go down 1, so it's going to look like this. And so we can draw that line going through here. And then our last one is 3x minus 1. So we know it passes through minus 1. And as we go across 1, we're going up 3. So it's going to be 1 and 2. Across 1, we go up to 5. And so if we go down 1, we go down 3. And so our region looks like it's going to be enclosed here. Now, we're going to have to check again because remember last time this kind of thing was a trap. So let's check. So if y is greater than minus 1, then it's going to be everything above this line. So that's looking good. If y is less than 4 minus x, that's this line. So that would be everything in this region up to here. And if y is less than or equal to 3x minus 1, that is going to be everything down this side. So this is region R. So like I said, we're going to look at why do these equal sign make a difference. And in this question, they don't. So they want us to shade this. So let's shade it in. So the difference between this question and one where an equal sign will matter is, for example, if they didn't ask us to shade this region and instead they asked us to show by putting a cross, so something like this, on coordinates, the region that is satisfied by these things. Instead, we would have to, usually if we wanted things where there wasn't an equal sign, we just cross everything that was inside here, like this. But because now we've got things that can also be equal to this, we also have to cross all the coordinates that lie on these edge lines as well. So this would be the difference here if we were to have some question like this. Okay, we'd also cross this one as well. But in this question, they're not asking us to show by putting crosses, they're asking us to shade. So the way we're going to leave it, I'm a little bit scared to rub out these crosses, so I'll leave them there, is we're just going to shade around edge and then just write the letter R in the middle. And this is how you would leave your answer. So hopefully this all makes sense. Thank you for watching.